So, good afternoon, student. So, today we have discussed a experimental on determination of dissolved oxygen. So, first of all, what is in by dissolved oxygen? So, the terms of dissolved oxygen is used to describe the amount of oxygen in water or wastewater. So, the dissolved oxygen content of water influence the by source, raw water, temperature, treatment, and chemical or biological process taking place in the distribution system. The presence of oxygen in water is good sign. Depletion of dissolved oxygen in water supply can the microbial reduction of nitrate to nitrate and sulfate to sulfide. It can also causes and increase the concentration of ferrous ion in the solution. So, in short, dissolved oxygen is defined as the amount of oxygen present in water or wastewater. The following are the chemical is used for dissolved oxygen or glassware. So burette stand, then the 300 ml of standard BOD bottle is used, then wash bottle, then conical flask, and the chemical is magnesium sulfate solution, alkali azide, sulfuric acid concentration, then starch indicator, sodium thiosulfate, then distilled water, potassium hydroxide, potassium iodide, and sodium azide. So these are the glassware is used, and these are the chemical are the used. So this is the procedure chart of the dissolved oxygen. So by same the procedure chart, we can conduct the experiment. So go to the experiment. So first of all, our object to determine or to estimate the dissolved oxygen in given water sample. So start the practical. So first of all, standardization the sodium thiosulfate solution. So fill the burette with the sodium thiosulfate solution. So go to the next step. Take a 10 ml of potassium dichloromate K2Cr2O7 in conical flask. Then add the 2 ml of hydrochloric acid HCl and 1 spoon of potassium iodide Ki powder in a conical flask. Then the 1 spoon of Ki crystal. So question is, what is the normality of potassium dichloride solution is taken? So 0.025 normality is taken. So answer is correct. Then go to the next step. So titrate the sample against Na2S2O3. Add the 2 ml of starch indicator. Adding the starch indicator, the colors turn to blue. So titrate against Na2S2 until the color is becomes colorless. So question is asked, solution color turns after the adding the starch. So blue. So answer is correct. Then go to the next step. So this is a observation table. So we can find out the normality of Na2S2O3 by using this formula. N1V1 is equal to N2V2. So your N is equal to normality of solution. So by calculating, so N1 is 0.025. Your V1 is 9.8 into N2, the normality of 0.025 into 10. So your answer is 0.06. So 0.06. Check your answer. So answer is correct. Then go to the next step. So determination of dissolved oxygen. So fill the BOD bottle with sample. So which of the following indicator is used during the titration? So starch indicator is used. So go to the next step. So add the 2 ml of magnesium sulfate in BOD bottle. Add the 2 ml of alkali hydroxide solution. So close the bottle tightly. So shake the bottle. So precipitate is settled down at the bottom of the bottle. So go to the next step. So add the 2 ml of the concentration H2SO4. So close the bottle and shake the bottle for 5 to 10 times. Then go to the next step. So take a 200 ml of the sample in conical flask. So titrate the burette with sodium thiosulfate. And go to the next step. Then titrate again Na2:O3 by adding the 2 ml of starch indicator. So add the 2 ml of the starch indicator. So color change to blue. So titrate. If blue color turns to colorless, so your initial Biuret reading is 0 and final Biuret reading is 5.7 ml. So find out the dissolved oxygen in mg per liter for using this formula. So formula is Na2 normality. So normality is 0.025 into volume. Volume is a 5.7 into 8,000 divided by volume of sample taken 200. So your answer is 5.7. So answer is 6.84. So what is the acceptable range of the dissolved oxygen in drinking water is 4 to 7 mg. So answer is correct. So the conclusion is acceptable limit of dissolved oxygen in water 4 to 7 mg per liter. The water with DO less than 4 mg per liter is extremely harmful to drink. The water sample has a dissolved oxygen is 6.84. So it is as per BIS ranges for drinking water. So the sample is used for drinking water. Okay. So in this way, we have successfully completed the practical on determination of dissolved oxygen. So next practical continue next lecture. Thank you.